One of the most critical aspects of electronics design is the ability to control precisely where the mouse cursor can take actions. The most basic element of the cursor snap system in Altium Designer is the grid, and you can operate grids in either imperial or metric coordinates. The grid is pre-configured with specific steps. In the Schematic editor, pressing G cycles through the 3 predefined grid step settings. These can be changed in Preferences under Schematic Grids. You can also set the electrical grid, which is the distance within which you need to be from an electrical hotspot, such as the end of a pin, in order for the cursor to snap to it and make the connection. The Shift-E shortcut in Schematic toggles the electrical grid on or off, but generally it's better to leave it on. In the PCB editor, the snap system is more elaborate. By default, you can work with a standard grid and switch between spacing presets using the G shortcut pop-up menu. This is quick and easy, but sometimes the board design and component placement needs more flexible snap controls. The Advanced Snap Options offers these advanced grids and snap settings. It's a little easier to explain by example, so here goes. In this design, I want to place an array of connectors which must align with this edge of the board, and another array aligned with the opposite edge. An easy way to do this could be to enable Snap to Board Edge in Advanced Snap Options, but for these connectors the reference point is the first through-hole pin, so it doesn't really help. As a side note, Snap to Board Edge is really helpful for placing slotted holes and mouse bites or through-hole pads for castellated edges. But for my design, I'll add a work guide by going to Place, Work Guides, Place Horizontal Guide, and set it to 4 mm, which is the offset from the front of the connector to the board edge at 0. When I move these components, they will snap to the intersections of the horizontal guide and the existing grid, which I've set to 1000 mils to illustrate the guide's operation. But I want these connectors centered at 19 mm intervals, so I'll add 2 vertical work guides, the first at an X offset of 9 mm and then 28 mm for the connectors to snap to. In this way, you can think of a linear guide as a type of manually placed grid over the existing grid, only items will snap anywhere along the guides where another guide or a grid line intersects it. Point guides can also be placed on the design. You can control the exact locations of the guides in the Snap Guide Manager, available from the Tools menu. The Snap Guide Manager also allows you to add, remove and disable linear and point guides in a tabular format. You can even import or export guides to ASCII text files. When you're done placing your components and other critically located objects such as mounting holes, you can disable the guides you're not using, re-enabling them later if needed. Besides using linear and point guides, you can also configure different rectangular and polar grids. You can get to the Grid Manager from the Tools menu, or also from the Snap Workspace menu down here. There is always at least one grid, which is the default Cartesian grid that you can change from the G shortcut menu mentioned earlier. To add more grids, simply click the menu button and choose Add Cartesian Grid or Add Polar Grid. Polar grids are a powerful and unique addition to the PCB editor, which are defined as shown here by origin, inner and outer radial range, angular range, and angular and radial grid steps. And for all grids, you can customize the fine and coarse color and line or point display selection. When dealing with multiple grids, these display options are important, and the priority order in the list of grids determines which grid is effective when multiple grids overlap. This makes it really easy to do things like place circular arrays of objects, like the LEDs on this board. These grid options also work in the PCB library editor, which can make it a lot easier to accurately build footprints. You may have seen this one in a previous design secret. Here I've used a custom polar grid to make this grey code-based rotary encoder, which uses these copper shapes on the PCB in combination